H bar to estimate population mean. And we shall use sample standard deviation to estimate the population standard deviation. We shall use sample variance to estimate the population variance. Okay. All right. So that's the next thing we're going to do. So we've answered question number 1. Question number 1 is asking us, what is the name? What is the name of the estimator? The estimator is point estimate. The estimator is the point estimate. So the estimator right here is the point estimate. So the point estimate is the value of the statistics that estimates the value of the parameter. So complete the statement below, you put your answer point estimate. Okay, well, let's go to the next question. Let's go to the next question talking about point estimate and so on. Let's talk about, as long as we are working on point estimate. So the question here, it says, compute the critical value. So very soon we shall be told to complete the critical value. Compute the critical value. Anytime I'm told to compute the critical value, I will have to draw a normal curve, and then they will give you a percentage that corresponds to 82% level of confidence. So 82% is in the middle, 0.82. And the question is, find the tails. Find the tails. The area on that normal curve is 1. So 1 minus 0.82. And 1 minus 0.82 is 0.18. 0.18. But there are 2 tails. So if I divide 0.18 by 2, I have 0.09. Therefore, the area to the tail is 0.09, 0.09 right here, 0.09 here, right here. So that is why they're asking me to find Z alpha over 2. So what does Z alpha over 2 mean? Z alpha over 2 means compute the critical value. So they are asking you to compute the critical value. So the critical values are alpha over 2 when you are given the confidence interval. Okay, so let's compute that. We already know how to compute that. We do know how to compute that. Area to the left. So area to the left. And so normal curve is symmetrical. So we already know that normal curve is symmetrical. So what we want to do is, when we find the area to the left and we found the z-score corresponding to the area to the left, and it's going to be a negative sign, we change it to positive. Okay, so I'm going to pull my calculator up and I will find the area to the left. I'm going to turn my calculator on. Remember how to find area to the left. You go to second verse, inverse norm. I hope you remember that area to the left is percentile. Find the 9th percentile. Area to the left corresponding to 9th percentile. So you write inverse norm. Inverse norm. Okay, and we will write the 9th percentile, that is 0.09, 0.09. All right, because this is a standard normal curve, the mean is 0, the standard deviation is 1. Now I want to get my calculator and find the inverse norm corresponding to 0.01 for 0.9. And the important thing is that because it is area to the left, the Z value there should be negative. So that area to the left is 0.09, 0.09. And this is a standard normal curve. So mean is 0, standard deviation is 1. And I am looking for the 9th percentile. What is the Z value corresponding to the 9th percentile? And that Z value is negative 1.34 to 2 decimal places. So that is negative 1.34. So that is negative 1.34. Because the normal curve is symmetrical, the Z value to the right is 1.34. The Z value to the right is 1.342 because the normal curve is symmetrical. The normal curve is symmetrical, so all you need to find is 1. So we did number 3. Let's do number 4. Let's do number 4. What is the critical value for? So I'm going to clear. I'm going to pull my whiteboard so that it can do a better job. And then I'm going to minimize it. Okay. All right. So I want to do number 4 using critical value. So I am going to clear. So find the critical value when the central area is, the area in the middle is 88%. 4. The center is 80%. So the first thing you want to do is draw a normal curve. So draw a normal curve. Show 88%, 0.88. Area under the normal curve is 1. So this is the area, 88%. So they're asking me to find what remains. If I take 88% from 1, or 100 minus 88%, what remains? I know that 100 minus 88% is 12%. 12% divided by 2 is 6%. Therefore, this area right here is 6% or 0.06, 0.06, 0.06. In other words, now I'm looking for Z alpha over 2. Why am I calling it alpha over 2? I divided alpha by 2. I divided alpha by 2. So Z alpha over 2 is what I'm looking for. And I am looking for the percentile corresponding to Z alpha over 2. By the way, the 6th percentile is what I have. I have the 6th percentile. So I will get my calculator again as usual and find inverse num 0.06. And by the way, I can just do second enter. And I am just replace 0.09 by 0.06. That makes my world easier. When I hit enter, then the Z value corresponding to 0.06 is negative 1.56. So this is negative 1.56. Negative 1.56. So that is the Z value corresponding to 6th percentile. That is the Z value corresponding to the 6th percentile. So I found the Z value to the left. Because the normal curve is symmetrical, the Z value to the left, to the right, is, I can just put in there. I'm going to switch this. I'll have 1.56. That's the Z value, 1.56. So the Z value to the right is 1.56. All I need to know is find the critical value to the left and switch the sign. When I switch the sign, it becomes the critical value to the right. Okay. Find the critical value to the right, left switch the sign, and it becomes the critical value to the left. All right. So we have answered question number 3 and 4 in the practice test. So the next question in number 5 says, determine the point estimate of the population proportion. Okay, the margin of error. And by the way, let me just write the formula for calculating population proportion. So I am going to write the formula for calculating the confidence interval of a population proportion. So if I am calculating the population proportion, I will first of all write the population proportion, P, is equal to point estimate plus or minus, then Z alpha over 2 multiplied by standard error. So that standard error that I have is square root of P times Q, P hat, Q hat, divided by sample size. Okay, so that is the formula for calculating the, but you know what, this is just the formula. I'm not going to do it with by hand, but if I'm told to calculate that, that tells me a lot of things. So if I am given the confidence interval already, so what I'm going to do is determine the point estimate of the population proportion, the margin of error for the following confidence interval, and the number of individuals in the sample with the specified characteristics X for the sample size provided. Okay, so I am given the sample size. So I am given everything that I need, lower bound and upper bound and so the lower bound is 0.343. So I am going to draw a line. So this is the line already I drew. So this one is 0.343, lower bound. The upper bound is I'm looking for what? 0.617. 0.617. That is the lower bound, that's the upper bound. The sample size given to me is 1,000. And then the center here is P hat. So I can quickly find P hat. P hat is the point estimate. So the point estimate is upper bound plus lower bound. So I can find P hat is equal to upper bound 0.617 plus lower bound 343 divided by 2. So I can get the point estimate. So what is the point estimate? I get my calculator and add upper bound and lower bound divided by 2. So I'll get my calculator. I am given upper bound and lower bound. The upper bound is 6.617. So 0.617 plus 0.343. When I hit enter, then divide by 2, my answer will be the point estimate. Therefore, the point estimate is 480. So the point estimate is 0.480. Okay, so I have answered the question about finding the point estimate. All right, so if I know the point estimate, upper bound and lower bound, I can find the point estimate. And I'm talking about question number 5. I'm talking about question number 5. The question number 5 told me to determine the point estimate. There are so many ways you can determine it, but this is one quick method. I'm given the upper bound and lower bound. What I need to do is add the upper bound and lower bound and divide by 2 to get the point estimate. And then if I'm told to find the margin of error, they also said find the margin of error. The margin of error is the distance between point estimate and upper bound. That is the margin of error. And what is the margin of error here? Upper bound minus 460. So I pull my calculator up. Okay, so 6.617 minus 480 is, let's do that again, 0.617, take away 0.480, and so that is the margin of error, 0.137. So the margin of error is 0.137. The margin of error is going to be the same again here, 0.137. So the margin of error is the number in the middle. So you can as well say that P hat is the midpoint of the line segment. P hat is the midpoint of the line segment. So the margin of error is the interval. And by the way, this quantity is called the margin of error. This quantity here is called the margin of error, ME. All right, so today we are calculating the point estimate, the critical value, and the margin of error of any given proportion. So we are working with proportion today. Proportion, if you don't get it now, you'll get it before the end of the day. So let's go to another question. When we solve many questions, we shall get what they are asking us. All right, so we have answered the question in number 5. Determine the point estimate again. So for number 6, they say determine the point estimate of the population proportion, the margin of error for the following confidence interval, and the number of individuals in the sample. And by the way, we can find the number of individuals. So let me pull back a little bit because we already know. Let me pull this. One thing we do know is that we can find the p hat is always equal to the those who are present over n, successes over n. And so anytime I am told to find n, then I can find it using the formula. So I am given 100 and n is 1,000 here. I can find the number of people who showed up. So I can use the formula let me bring it here. So 0.480 is equal to x over 1,000. All right, and this is over 1. If I multiply 1,000 with 480, I have, I'm going to just multiply, so get my calculator up. So get my calculator up. So I have 1,000 multiplied by 0.480. And my answer is 480 people. So 480 people was the success, the number of successes out of 1,000. So you can actually find, I'm going to clear the board and repeat exactly what I just did. I'm going to repeat in such a way that, okay, so I want to make sure I repeat it so that you get what I'm saying. Okay, whenever I am given, I'm told to find the p hat, which is the point estimate. The point estimate is the number of people out of the total, number of yeses out of the total n. Okay, and then we are given the lower bound and upper bound of that question. And the lower bound of that question, the lower bound of the question they gave us is 0.343, 0.343. The upper bound of the question is 0.617. The midpoint is p hat. The midpoint of the line is p hat. So if I can find p hat, which I can, so p hat is actually upper bound plus lower bound divided by 2. And I already know them. The upper bound is 0.343. The lower bound is 0.617. 0.617. When I'll get the p hat. And is 480. And I am told that the sample size is 1,000. So x over 1,000. 1,000. Okay. And this is 480, but this is 0.480 because it's proportion. Okay. But if I multiply 480 by 1,000, I am going to have 480. Therefore, x is equal to 480. Okay, so that is the question they asked us. They want